Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at reinterpret class in C++. So I've got the code from the last tutorial here. I'm going to get rid of this stuff about references here at the bottom. Now we saw that if you have a pointer of a superclass type to a subclass type, you might later on want to have a pointer to the subclass type, and you might want to cast the pointer of the superclass type back to the subclass, because it does in this case refer to a subclass. So we've genuinely got the subclass here, the subclass object. So it makes sense that we might want to cast it back to the subclass type. And we can do that with static cast, but the problem is this is very unsafe, because what if this parent class superclass pointer actually does point to a superclass object like this? Static class will still allow us to do that, and there are very few situations in which you genuinely want to do that. The superclass might lack methods that the subclass has, and you might try to call them using this pointer and your program will crash. So it would be nice if we had some kind of cast that could detect at runtime whether or not this makes sense, and let's say it could return a null pointer if it doesn't make sense. So we can actually do that with dynamic cast, and by the way, the code that I'm about to show you will only work if you've got runtime type information turned on in your compiler, RTTI, and that is turned on by default in GNU. But if you get different results to me in your code, you might want to check that you've got RTTI turned on, because this dynamic cast, unlike static cast, which is just a compile time thing, dynamic cast checks types at runtime to make sure you're doing something that makes sense. So now let's put an if in here, and I'm going to say if pbb equals null ptr. I'm using C++11 as it happens here. Then we can do cout invalid cast. Else I'm going to just output the address of the pointer as before, just to show that it looks like it's probably a valid pointer. We could go further and call methods using it, but I won't do that here. Okay, so if we run this now, we find that well, this gives us an error, because dynamic cast is kind of saying, well, it makes no sense to be casting pointers like this, because you've got a function in there that isn't virtual. So the actual error that I get is parent is not polymorphic. What we need to do to make this work is make this method in parent we need to make it virtual, and now this works. What we get is invalid cast, so it's actually returning us a null pointer, because it's saying, well, it doesn't really make sense to cast a pointer that points at a parent type object to the child type object. That's potentially very unsafe, and dynamic cast helpfully returns a null pointer in this situation to tell us that this is invalid. But on the other hand, if this is if it is a subclass object, or some object that we could genuinely makes sense to point this pointer at, then we get a valid pointer from dynamic cast. So it's actually doing runtime type checking there to make sure that we're doing something sensible. So if you can use dynamic cast, it's better to use that instead of static cast, because static cast doesn't do this runtime checking. So it's worth verifying this for yourself and seeing what results you get on your compiler. You might have to turn RTTI on somehow, but probably this will work out the box for you on your compiler. So just verify that you do actually get a null pointer if you do a cast, if you do an upcast, which doesn't make sense, and a downcast, which doesn't make sense, and check that it does actually work if your downcast does make sense, or casting down here from parent to brother. Okay, so until next time, happy coding.